Namaskar students. In this video, we will discuss about complex number class 11th mathematics. Here we will discuss some very important questions which will help you in understanding the concepts as well as a quick revision of the chapter will also be done. You will be able to understand the whole chapter quickly. Okay, so let us start. In this question, we are given that this expression is equal to x plus I by, okay, it is a complex number, and then we have to find x square plus y square. When we take amplitude of any complex number, suppose z is equal to x plus iy, okay, and if we take amplitude of that, it is like this. This gives us square root x square plus y square, okay, and we are requiring similar expression. So if we take amplitude of this expression, we can get similar result and we can find the required thing. So from this given equation, we are taking modulus both the sides. Fine. So from here we get modulus of a square plus 1 whole square upon 2a minus I is equal to modulus x plus iy. Okay. This is the same thing according to the formula. So we will get this value as root x square plus y square. So we are getting closer to the required result. Now what happens here? Modulus of few things. Okay, this is like purely real thing. Here no complex quantity because no I is here. So it will be out. Fine. So we have only 1 upon 2a minus I. Okay. We also know one thing, that z1 upon z2 modulus is equal to modulus z1 upon modulus z2. Okay, so this will also give us modulus 2a minus I. This will be a and whole square, and similarly the majority part is minus 1 and whole square. This is square root x square plus y square. Okay, we have got this. So when we simplify this, see, we have to take square root both the sides. So here squaring both the terms, what we get? This side we will get x square plus y square, and this is the required thing. Okay, so we get x square plus y square, which is equal to a square plus 1 power 2 already there, and power 2, it means this will become power 4. Now this thing is square root and a square. This is our required answer. Here we are given these complex numbers and we have to find the argument of the product. Okay, it means we have to find the angle. तो सारे मेथड हम डिस्कस करेंगे यहाँ पर कौन कौन से मेथड एग्जिस्ट कर रहे हैं. So first method we are discussing here. What is the theorem? Theorem says that cos theta plus I sin theta, we can write e to the power I theta. Okay, this is the Demagogue theorem. So here we will write each and every term in e to the power something. So for that we need some angle also. So this 1 and root 3 we know, 1 is square and root 3 is square and a square root. This value gives us square root 4 and this is 2. So we multiply and divide by 2. Okay, so this becomes, on dividing by 2 we get 1 upon 2 and root 3 by 2. Same here, root 1 square plus 1 square gives us root 2. So multiplying and dividing by root 2 we get 1 by root 2 and I upon root 2. Okay, now this term is same. Okay, no change in this. So for these two terms, let us see what happens. So 2 and root 2, and this is what, 1 upon 2 and root 3 by 2. Cos we know, cos 60 is 1 upon 2. So this is cos 60, that is pi by 3, plus I sin, this is also sin 60, so sin pi by 3, and this is 45, cos 45 and I sin 45. Okay, now the third term is cos theta plus I sine theta. So when we multiply these three terms, so before multiplying we can write them in to e to the power I theta notation. So this will become e to the power pi upon 3 I. This will become e to the power pi upon 4 I. This will become e to the power I theta. So these are in multiplication. So it will become e to the power, this will be in addition. So I theta plus pi upon 3 plus pi upon 4. Okay. So 4 plus 3, 7 pi upon 12. So this is e to the power I theta plus 7 pi upon 12. So this is just a constant, leave it. Our argument will be this much. Okay. So we need to find the argument. So this is our argument for this question. Fine. This is our fun method. Okay guys. Now let us see the other method for this question. Second method says the argument of these terms will be argument of this term plus argument of this term plus argument of cos theta plus I sine theta. Okay, this is according to the formula. So what is the argument of this? Here the argument is pi upon 3. Similarly, for this we see 1 plus I is equal to, here the argument will be pi upon 4. Okay, and here clearly the argument is theta. So we see that argument of this will be pi upon 3. Here the argument will be pi upon 4. And here the argument is theta. On addition we get 7 pi upon 12 plus theta. This is the argument for the question. Okay, you can also do in this manner by finding the argument separately. In this question, this expression is given us and we have to find the greatest and least values of modulus z plus 1. Okay, that is a different term, modulus z plus 1. It is a different term, modulus z plus 4. And now we have to do something. So if we assume that z plus 1 is equal to some other variable, let us say y. So from the given equation we see z plus 4 can be written as this plus 3. Okay. Now if we have assumed z plus 1 as y, so this will be y plus 3 lesser or equal to 3. Now we have to remove this modulus. There are two ways. Either we can do square both the sides or we can use the property of modulus. So suppose we write the property of modulus. So this will be minus 3 lesser or equal to 5 plus 3 lesser or equal to 3. Now subtracting 3 from every term, minus 3 and minus 3, this gives us, this is cancelled, minus 6 lesser or equal to y lesser or equal to, this is 0. Okay, so we have got this thing. And what is y? Y is actually z plus 1. So we have got the value of z plus 1, which is minus 6 lesser or equal to 0. But remember guys, this is not the answer. Here the values of z plus 1 are minus 6 and 0. Okay, so minimum value of z plus 1 modulus is what? Modulus of these two. Here the modulus of this value is 6 and modulus of this value is 0. So minimum of z plus 1 is modulus of 0, that is 0, and maximum value of mod z plus 1 is modulus of minus 6, this is plus 6. Okay, second method you can also do square from both the side. Y plus 3 whole square is lesser or equal to 9, then you can simplify, then also you will get the same thing. Here in this question we have to find the value of this expression. Here the iota is just a usual notation, iota is root minus 1. Okay, and we have to find the value of this expression. Here this can be done in many ways. We know that powers of iota, iota square is minus 1, I to the power 3 is minus I, and I to the power 4 is 1. Okay, this we know. We can use that thing, and one more property we know, I to the power 4n is also 1. So we can use this property also to simplify all the terms. But here I will do something else. I'll take common from numerator and denominator first. So I see that I to the power 584 is common. So what we get? 6 and 2 is 8. And here we get I to the power 6. Here we get I to the power 4, I to the power 2 and 1. Similarly, when we take maximum common, we see I to the power 574 is common. So 574 is common. Now what we get? I to the power 8, I to the power 6, 4 and power 2 and we get 1. Now we see the similar term is there. So why to waste time? This is cancelled. Now we have this thing only. So this will be iota to the power 584 minus 574 and this is iota to the power 10. Now you know this can be written as iota to the power like 8 plus 2. Iota to the power 8 is like this. So this will be iota to the power 4 square. It means 1 square into this term is minus 1. So we get the answer as minus 1. Here in this question we are given that this complex number x plus iota y is equal to this thing. And then we have to find the value of this expression. Okay. Both sides we have complex number. But we know one concept that if z is equal to x plus iota y, modulus of z is what? This is x square plus y square. So we can use this concept. So we try to take the modulus and proceed the solution. So when we take modulus, we get x plus iota y is equal to modulus of this thing, a plus iota b upon c plus iota d. But modulus and square root, we can like shift this operation. This can be interchanged. So we will do square root later and we do modulus first. So a plus iota b and c plus iota d. Now again we have the property that modulus z1 upon z2 is equal to modulus z1 upon modulus z2. So this term further can be written as modulus a plus iota b modulus c plus iota d. And this we know according to the formula. This can be simplified. It will be square root a square plus b square. Similarly, this will be square root c square plus d square. Okay. So we have the values now. And left hand side, when we take this modulus, this will be square root x square plus y square. So if we square both the sides, what happens? This square root will remove. So we get x square plus y square. This is with this square root will go. So we have a square plus b square upon c square plus d square. Still we have power 1, but here we need to find power 2. So we square once again. So once again squaring gives us a square plus b square and c square plus d square. So this is the required value for the given expression. Okay, so let us see the second method. Second method says if z is this one, then z bar, that is conjugate of z, will be x minus iota y. And if we multiply these two things, this is product of these two, which will give us x square plus y square. Okay, it is nothing but modulus of z whole square. This is the property. Now from this given equation, suppose this is equation number 1. If we take conjugate of both the sides, then x plus iota y, conjugate of this will be conjugate of this thing. So this will be conjugate of a plus iota b upon c plus iota d. Okay, conjugate of this entire term. Now again, this conjugate, it means z1 upon z2 conjugate will be equal to conjugate of z1 upon conjugate of z2. So we write this term once again as a plus iota b conjugate and c plus iota d and conjugate. So what we have done, conjugate of a plus iota b, we simply change the sign. This is a minus iota b. Similarly here, conjugate of this term will be c minus iota d. So now we have got this term as equation 2. Now look carefully. We know this property that whenever we multiply z into z bar, we get z modulus z whole square. It means x square plus y square we get. So see the LHS here in equation 1 and 2. If we multiply these two terms, we get the similar result. So equation 1 multiply equation 2. What it gives? It gives us x square plus y square. Now in the RHS, the square root is there. So inside this square root, we get the product of these two terms. So a plus iota b, a minus iota b. And here it is c plus iota d and c minus iota d is there. So what is this product? This is nothing but, similarly, this is root a square plus b square. Okay, and this is also c square plus d square. But we need to find the value of what? The square of this term. So once again we are squaring both the sides. So we get this term as a square plus b square and c square plus d square. This is the answer for the required given term. So in this question we are given the value of theta lies between pi to 2 pi, and this complex number z is 1 plus cos theta plus I sin theta, and we have to find the modulus of z. Simple thing. But still, because of the values and the given thing, it is a little bit different. Okay, so let us see how it can be done. So here we see 1 plus cos theta. We know cos theta formula is 2 cos square theta by 2 minus 1. And similarly, sin theta can be written as 2 sin theta by 2 into cos theta by 2. So what happens? This one is cancelled. Now, can we take something common? Yes, 2 cos theta by 2 can be taken common. So what we get? Cos theta by 2 and plus I sin theta by 2. Okay, this term we have got. This is z. Now we have to find modulus of z. What is modulus of z? This is modulus of this entire term. Okay, and since this is just a real number, so this can be taken out anytime. Fine. So modulus of this term will be 2 cos theta by 2 into modulus of cos theta by 2 plus I sin theta by 2. Okay, and we know the property of modulus. Modulus of x plus iota y is square root x square plus y square. So this value is also what? Square root cos square theta by 2 plus sin square theta by 2. This is a well-known identity. This value is 1. So we get modulus of z as 2 cos theta by 2. But one thing is that when we find modulus, the value should be positive. It cannot be negative. And because of this thing, just see guys, what is this? Theta is lying between this range. It means theta lies from here to here. Fine. Here the important thing is that when we take modulus of this, 2 cos theta by 2 is come out. Fine. But this term is positive. Okay. Why? Because we are taking the modulus. So when we see here theta is from pi to 2 pi. So when we divide throughout and when we know theta by 2, this is what? Theta by 2 is from pi by 2 to pi. It means from here pi by 2 until pi. So it means this value will be there in second quadrant. So when theta by 2 in second quadrant, then cos will be always negative. So to make this value positive, we have to write one minus sign. Okay guys, this is the important thing for this question, okay, which you need to understand. I hope this is clear to you. We will meet again with more amazing videos and many more important things for you. Till then, take care. Bye bye.